Tran, and today I will be going over Lab 2 over projectile motion. So here's the table of contents. There's introduction, the experiment between theoretical data. We're going to compare the two data sets we get, and then we're going to wrap up with what-if questions. So introduction. What is this lab? The purpose of this lab is to observe an object, a paper ball in this case, moving in a curved motion. Unlike a last lab where we observed an object moving in mostly one direction by rolling, this object will be thrown with more factors to consider. The object would then be compared to a computer model simulating the exact same experiment. What physics principles did we use? One of the physics principles we use is the momentum principle, which is the net force is equal to the change in momentum over change in time. Second physics principle we use is force is equal to mass times acceleration. Another one we use is drag force is equal to negative b times velocity squared times v hat. And then a last formula we will use is t, which is the time it takes an object to reach its highest point, times initial velocity times sine theta over g, which is gravity. So, to the lab and the data. The paper ball was thrown at an arc with a meter stick used for scale. The ball is the system, gravity and drag are the surroundings. Tracker is used to record the data of the experiment. And then here's a clip of the lab. And then here are the results we got from putting it into Tracker. As you can see, as time moves on, x goes further to the right, and then y heads towards the negative y direction. And then here's the graph, y versus time, so it's a bit easier to see. And then here is the glow script for the computer simulation we did. On the left, you can see the initial conditions. These help set up so that the ball will travel as closely to the original experiment as possible. And then on the top right here is factoring in drag in our computer experiment and just using it to figure out the ball's motion. And then on the bottom you can see the experiment the computer did. Okay. And then here are the graphs we got from our computer experiment. On the left is the chart without drag force. On the right is when drag force was incorporated. As you can see with the just gravity, it's slightly larger than the one without drag force. This will be made more clear in this next slide where you can see all three different data types. The actual experiment had much higher values than the other two. You can see how gravity is greater than the one with drag and gravity. Why is there a discrepancy between the data? There are many sources for error. There could have been external factors acting on the system in the lab while recording the video, such as like wind or maybe there was a different, there's a vent above the ball and just causing some motion. There could have been coding errors, which is very likely, as well as issue with the tracker software or just misusing the tracker software in my case. And some what-ifs. So one of the questions asked if the ball reaches terminal velocity, which I don't believe it does, since if, as you can see in this velocity of y versus time graph, if f net equals 0, which is when it reaches terminal velocity, the graph should have leveled out and been a horizontal line, but in this case you can see it's constantly changing throughout the time. And if another what if is if the ball was thrown straight up into the air instead of in a parabola shape, like how it was in the experiment. If that was the case, the ball would take longer to reach the ground if it was thrown straight up rather than in a horizontal curved motion. Since if a ball is thrown straight up, theta, the angle thrown up would be at 90 degrees, and if sine 90 is 1, right? And anything less than that is less than 1, which will reduce the velocity on the top, therefore shortening the time it takes for it to reach the top, therefore being shorter time to while thrown horizontally rather than vertically. Thank you.